Good afternoon, everyone. How was your test today? How much score you got? Good afternoon, Gauri. Good afternoon, Chichini. Okay, so I think you had a good exam today in the morning. We will discuss few important topics, in fact, important questions of the test, which are very, uh, which have very high probability to come in the exam. The similar questions that may come in the exam. So that's what we are going to discuss. The agenda is simple. Do that questions which has high probability to come in NEET exam. Okay, so let's start. First question on our screen. Have you attempted this question? Two particles are projected in air with same speed at an angle theta 1 and theta 2. Theta 1 and theta 2. Both are acute angles to the horizontal respectively. Now, let's suppose two particles are like this is particle 1, this is particle 2. Okay. The question says if the maximum height reached by the first particle is greater than the second. So first of all, we should write the what is the formula for maximum height in projectile motion, and everyone knows that maximum height is u square sine square theta divided by 2g. This is the formula for maximum height. Now, according to the question, you can see that initial velocity with which the particle is projected is same. G is the gravitational, you can say, acceleration due to gravity, which is also constant. So you can clearly see that H depends on sine square theta. Now, according to the question given is H1 is greater than H2. The first particle is greater than the second particle. The height attained is H1 is greater than H2. If you see that, you can clearly state from here that H is directly proportional to sine square theta. That means sine square theta 1 is greater than sine square theta 2. All other factors are independent. That means theta 1 is greater than theta 2. So which option is correct out of these? Theta 1 is greater than theta 2. That is option number A is correct. Is the thing clear? So from this question, after solving this question, what is your task? To remind time period, or you can say time of flight, to remember range. So after remembering this formula, it will be very easy for you. Revise these things. Okay. Moving further. There is another question. Question says the inner and outer radius. The inner and outer radius of a toroid are 22 and 28 centimeter. Do you know how toroid is? This is the inner radius. This is the outer radius. And there is a wiring. You know that thing that we have explained, something like that. This is our toroid. Clear? So for a toroid, what is the magnetic field? Magnetic field for a toroid, outside is 0, inside is 0, but in the coil is mu naught Ni over 2 pi r. In this relation, small r is the average radius. Average radius. So the inner radius is 22, outer radius is 28. So average radius will be 22 plus 28 divided by 2. This is the average radius, and you can see that it will become 50 by 2, that is 25 centimeter. So average radius is 25 centimeter. Now we just need to put the values here. Put the values. B is equal to mu naught is what? 4 pi into 10 raised to the power minus 7. Total number of turns were 3500. Current is 10 ampere divided by 2 pi, and R is what? 25 centimeter. That is 25 into 10 raised to the power minus. Now you can solve it and you will get the answer. You can solve it and you will get the answer. Pi and pi 2, and that will be 2 times 5, 700. So that will be 28 into 10 raised to the power minus 3. 28 into 10 raised to power minus 3 Tesla, that will be the field. So if you see which option is correct, option A will be correct. 2.8 into 10 raised to power minus 2. This is the correct answer. Is it clear, everyone? Next question. In a nuclear fusion reaction, mass defect is 0.25%, then energy released in fusion of 1 kg masses. So what is it? The mass defect is 0.25%. You know that energy released is mass defect into c square, where c is the speed of light. That is the Einstein's relation. E is equals to delta m into c square. So delta m is given as 0.25% of 1 kg. So if we calculate delta m is equals to 0.25% of 1 kg of 1 kg. That is 0.25 divided by 100. This is the percentage into 1. So that will be, if you divide it, 20 will be added. That is 1 by 400 kg. This is the mass defect. Now put the value of everything, you will get the answer. So E will be 1 by 400 into C is what? Speed of light is what? 3 into 10 raised to the power 8 whole square. You can calculate it. 1 by 400 into 9 into 10 raised to the power 16. Now it's up to you. You can divide it and you will get the answer. You can divide it. Whichever is the option, you can divide it. Or I will divide it for you. Let's do it. If I cancel these two zeros, value of C is a constant. It's a constant if we take it as a 3 into 10 raised to the power 8. It's a constant speed of light. Okay, have you calculated it? If I can cancel out these two zeros, it will become 14. The power will remain 14. So if I divide 9 by 4, that will be 4 into 2, 8. Remaining is 1. So again 2. And into 10 raised to the power 14. So if I correct option, if I see that in the option list, option C will be correct, which is 22.5 into 10 raised to power 30. Very good. I think Gauri has answered correctly. Very good, Gauri. Moving further. Is the concept clear? If you know the mass defect, what you should remember? If you know the mass defect, you can easily calculate the energy. Now, one more thing to be remembered here that I will tell you. These options are in joule. Sometimes These options may be in mega electron volt. These options may be in mega electron volt. So in that situation, and mass defect is also, so remember one thing, if delta M is in, you remember the unit, atomic mass unit, the unit that we have studied in nuclear physics, atomic mass unit. If delta M is in AMU, then energy will be delta M into 931.5. And this will result in a unit mega electron volt. Remember, this is also a very famous unit of energy. This is mega electron volt. What you should do if you have delta M in terms of AMU or atomic mass unit, then multiply it by 931.5 and you will get the answer in mega electron volt. Keep it in mind. Now, moving further. Question says, a charged particle having drift velocity of something in an electric field, this one has a mobility. Mobility they are asking. So one thing for you, I will ask you, mobility is represented by mu, is defined as drift velocity per unit applied field. Remember this formula. I think check the spelling. This is written as remember this formula. What is the value of VD? Question says drift velocity is 8 into 10 raised to the power minus 4 divided by electric field is 6 into 10 raised to the power minus 6. You can divide it. That is 4 by 3 into 10 raised to the power 2. Clear? If I divide it, that is 1 point. Okay. Have you divided it? I am not solving it again. So that will be option number A. Very good. Very good, Gauri. That is option number A. Moving further. You can solve it. Easy question. Now in this register, in this question, this is a color coding of carbon registers. Do you know what is the color coding of carbon register? There are few strips here. This is first strip, second strip, third strip, and fourth strip. When we talk about color coding of carbon registers, first two strips gives the value of magnitude, that is two digits or the digits of the magnitude of the resistance. Third digit or third strip gives the power, 10 raised to the power. And the final strip, this final strip gives the tolerance. So silver color has a tolerance of 10% plus minus. Out of these, there is a gold. Gold color has a tolerance of plus minus 5%. And there is another choice for this, that is no color. If fourth strip has no color, then it will be 20%. This is the tolerance I am talking about. And if I talk about this red, yellow, blue thing, this is black has 0, brown has 1, red has 2, orange 3, yellow 4. Again, green and blue 5 and 6. Do you know this table? You don't know this table. Okay. Okay, very good, Gauri. You know this table. This is generally pronounced as B.B. Roy of Great Britain has, or you can say visited Gateway of India. Visited Gateway, there is a another option, Gateway of India, visited Gateway of India. There is no space. You can say, you can remember it. B.B. Roy of Great Britain visited Gateway of India, or you can say B.B. Roy of Great Britain. B.B. Roy of Great Britain has beautiful wife. You can also relate in the same way. So out of this, if I talk about the question, the first strip is of red color. Red color means 2. That means 2. Second is of yellow color. Yellow is means 4. That is 24. Third strip gives the power 10 raised to the power blue color. Blue color has a power 6. 10 is power 6. Silver has a tolerance plus minus 10%. That is 24 into 10 raised to power 6 plus minus 10%. So which is option number A, B, C, D? This question you should answer. Everyone. This is up to you. Possibly represents electrostatic field lines. In the first option, if I see, there are two positive charges. This is positive and this is positive charges. And what you know, that field lines emerges from positive charge and terminates at negative charge. But in this diagram, you can clearly see that field lines are emerging from positive and terminating at positive charge, which is impossible. They should terminate at negative charge. In the option B, there is a metal surface. This is a metal surface. And you can clearly see that field is not perpendicular to the metal surface, but actually field is perpendicular to the metal. Okay. Now talking about C, positive rays are, field lines are emerging from positive charge. That's good. And they are terminating at negative charge. Field is coming at negative charge, emerging from positive charge. So C is correct. What's wrong in D option? What's wrong in D option? Can anyone answer? What is wrong with the D option? Gauri, Divya, what's wrong with the D option? There is a statement, very good, someone has answered. Positive or attractive circular path. Very good, Chichuni. The field lines do not form loops. And you can see here, there is a loop. You can see there is also a loop. So they cannot form closed loops. That's why statement D or option D is wrong. Very good. Option C is correct. Now, this is a good question. Question says, you can see it from the diagram. There is a square of 10 and 10 and 10 centimeter. And at a height of 10 centimeter from the one corner, a charge 20 microcoulomb is placed. You need to calculate the magnetic flux through the square. From this square, you need to calculate the flux. Now listen to me very carefully. This is a square sheet, and this will become a cube. Now, what I am doing, according to the question, the square sheet is this one, which is given to us. This is the square sheet of 10 by 10 centimeter. Now, at just above some height, or you can say 10 centimeter height, there is a charge placed Q. Q has some value that is 20 microcoulomb. But now this is the situation. Now, according to the Gauss theorem, the flux linked with a closed surface is charge inside divided by epsilon naught. I think you know the Gauss theorem statement. This charge is not completely enclosed. So to enclose it completely, what I will need 7 more cubes of same identical size. I will need 7 more cubes of identical size to be placed, one on the left of it, two on the back side of it. So total four on the ground floor and four similar on the first floor of these boxes. So total 8 cubes are required. And out of these 8 cubes, the flux linked with our cube, this cube, the flux linked with imaginary cube is total cubes are 8. So Q by 8 epsilon naught. I think you will miss something in this. In this, now I am telling you, phi will be Q by epsilon naught. This is the flux linked with 8 cubes. So flux linked with 1 cube will be Q by 8 epsilon naught. Now there are 6 faces in it. There are 6 faces in it. Out of these faces, this adjoining face 1, adjoining face 2, and adjoining face 3. These 3 faces will have zero flux. That means all the flux is connected or attached with or linked with only 3 remaining faces. So I will say flux linked with one phase, that is phi dash is equals to Q by 24 epsilon naught. So this is going to be our answer, Q by 24 epsilon naught. Now this is a standard question. Every student who has prepared something has gone through with this question. This is a very simple and very doable question. And students, remember the answer. What you should remember, when a charge Q is placed at one of the corners of a cube, the flux linked with the cube is Q by 8 epsilon naught. And flux linked with the one phase is Q by 24 epsilon naught, in which 3 faces have zero flux. Which 3 faces has zero flux? The faces which are attached to the charge. This is the charge. 3 faces which are attached to this charge have zero flux because field lines will not cut them. So you should remember this relation. For a cube, now Q is a value 20 microcoulomb. Epsilon naught has a value 8.85 into 10 raised to power minus 12. Put the value and you will get the answer. I am not going to solve it now because it will take a lot of time. You can put the values, and get the answer. Clear. These results are to be remembered. Now this is again a very simple question. Two vectors A and B are perpendicular to each other. Then value of alpha. Where is alpha in this situation? This is alpha. This is alpha. Okay. So I am removing this part. Okay. So let's solve it. When two vectors are perpendicular to each other, that means angle between them is 90. Zero. So whenever you see there is a 90-degree angle perpendicular, then you can clearly state that A dot B should be 0. Now further, value of A is I minus 3j plus 2k dot 2I plus 3 alpha plus 5k. Very good, Gauri. Is equals to 0. Gauri has answered option D. Let's check it. Now, When you are doing dot product, what is the specific rule? Multiply I with I, J with J, and K with K. That's what we need to do. So if I multiply I with I, that will be 8 minus 9 alpha plus 10 is equals to 0. So it will become 9 alpha is equals to 10 and 8, 18, that is minus 18 minus 9 alpha. So alpha is equals to 2. I think Gauri has answered D option. Very good, Gauri. Gauri, have you solved this question after the exam or you have solved this in the exam or during the exam? Now, this is the question from wave optics during the exam. Very good, Gauri. Now, this is the question on polarization of light of wave optics. Question says there is a polarizer and an analyzer are inclined to each other at an angle theta. So let's draw it. There is a polarizer. That's how we draw it. And there is an analyzer. And they are inclined to each other by an angle theta. The angle between them is theta. Let's state here. If the intensity of light, let's suppose light is coming from this way, this is the light, and they are saying the intensity of light emerging out from analyzer is I naught. That means light coming out here is I naught. Then the intensity of unpolarized light incident on polarizer is, so here light intensity is to be asked. Now listen, let's suppose the incident light is I. The intensity of light which is incident on polarizer, this is polarizer, this is analyzer, is I. So we know that when the light passes through the polarizer or when unpolarized light passes through the polarizer, its intensity becomes half. Its intensity becomes half, so that means it will become I by 2. It will become I by 2. And when this polarized light passes through the analyzer, the intensity of light is given by I dash is equals to initial instant intensity. I am writing the formula, so don't think that I have placed the values. That is incident intensity into cos square theta. This is the relation. Now I am explaining the terms. I dash is the outcoming intensity. I incidence is the light intensity which is incident on the analyzer. Theta is the angle between them. Now place the values. Outcoming light intensity is given as I naught is equals to incident light has the intensity I by 2 cos square theta. Angle between them is theta. So we have to calculate I. So from this equation, I will be 2 I naught upon cos square theta. 2 I naught upon cos square theta, which is option number 2 I naught upon cos square theta, which is option number C. So what is to be remembered after this question? That the intensity of light after passing through the polarizer becomes half. One thing to be remembered. Another statement, this is known as law of Malus. This is known as law of Malus. According to this law, the outcoming light from the analyzer is equals to incident light into cos square theta, where theta is the angle between analyzer and polarizer. So you can remember these two formulas. These are very basic and important formulas. Moving further. This is the question of rotational motion. that we have studied previously in a few days ago, I think. Question says a disk rolls down on an inclined plane of inclination 37 degree. There is an inclined plane of inclination 37 degree. And there is a disk. This is a disk which is rolling on this inclined plane, pure rolling. The acceleration of center of mass of the disk. Now, there is a standard formula for this. Acceleration of center of mass for pure rolling motion on an inclined plane is g sine theta divided by 1 plus k square by r square. Now tell me just one thing. What is k here? What is k in this relation? If you have studied in the previous class, you must know. Anyone? Anyone? Say at least yes or no, so that I'm just on standby, waiting for your answer. If you don't know, you can say, sir, I forgot, or I don't know. Forgot, sir. Very good. Just answer like that. K is the radius of gyration. K is the radius of gyration. And what I think I have told you the value of this k square by r square for most of the objects. For ring, it is 1. For disk, it is 1 by 2. For hollow cylinder, it is 1 by 2. I have told you lot of values of k square by r square. So I am just going to put the values. A is equals to G sine 37. I put the value of sine 37 directly. Do you know the value of sine 37? If you don't know, then remember it. Sine 37 is 3 by 5 divided by 1 plus k square by r square for a disk. For a disk is 1 by 2. So I will put the value again 1 by 2. So it will become 3g by 5 divided by 2 plus 1, that is 3 by 2. Or you can say 3 and 3 will be cancelled out. It will be 2g by 5. 2g by 5. This is the standard relation that I have told you during the classes, that acceleration is g sine theta over. I have told you three relations. One is acceleration, one is time to reach the ground, and one more I have told you, I think, which is just recall me. What is the other relation? Now this is important question. Have a look at the question. Question says a circular portion of radius r is removed from a uniform circular disk of radius 4r. So first of all, there is a uniform circular disk of radius 4r that I am going to draw. Uniform circular disk of radius 4r is here. I don't think it will remain. Shit. Okay, let's draw it again. Let's suppose this is a disk. Now, what are they saying? This has a radius of 4r. Out of this, a small circular portion of radius r is removed. Something like that. Something like that, a portion is removed from this. So the remaining portion is something like that. This is the remaining portion. Now I will put the values. This has a radius r. This is also radius r. Total radius is 4r. So this remaining portion is also 2R. Is it clear? Now, they are asking then the shift in the center of mass will be. So in such type of questions, remember one thing. Remember one thing. Let's suppose this disk has a uniform mass density of sigma. Has a uniform mass density of sigma. And this portion is empty actually. This portion is actually empty. There is nothing in this portion. Now what I am trying to do, I will put two masses inside this. Now this is the actually hypothetical thing, which is not possible. But what I am doing, I am placing two masses. One is positive mass, one is negative mass. So don't get confused. Sir, what is negative mass? This is nothing. This is just a concept. The same question will be in electrostatics as well. That's why I am doing it in this way. What is the way? Just put the two masses inside this hole. One is positive mass, other is negative mass. Overall mass is zero still. This portion is empty. So I am putting two masses. One is positive mass, one is negative mass. Overall mass is zero still. So I am putting two masses. One is positive sigma, other is minus sigma. Clear? So if I put the positive mass here, this hole will be completed and it will become a complete disk. It will become a complete disk. And there is another body you can assume which has a negative mass. Now I am telling you, listen to me very carefully. This complete disk has its center of mass at the center. So this is the center of mass of, let's suppose this is O point, and the center point of this small hole is O dash. Okay. And the center of mass of this negative mass or this negative mass is at O dash. O dash. This is O. And the separation between these 2 points is 3R. You can see from the diagram, separation between O and O dash is 3R. Clear. Now one more thing. What is the mass of the whole disk? I am supposing it to be M1. What is the mass of the small hole? That is, let's suppose it to be M2. Clear? But this is negative mass, so I am taking it to be negative M2. Till now, everything is clear. Now, what will be the center of mass of this combination? So, center of mass, the x coordinate of center of mass will be, I am taking this O as the origin. This O as the origin. So, center of mass of this two mass system, I think you have studied the formula of center of mass for two mass system. That is the point you have taken as origin. The mass opposite to that, that is M2, which is minus M2 actually, into the separation between them. The separation between them is 3R divided by total mass of the system. Total mass of the system, M1 is positive and M2 is negative. Now I am just going to put the values of M1, M2, etc. Minus is already there. M2 is the mass of this smaller hole. This smaller hole has a density sigma and area is pi r square into 3R divided by N1 is the mass of the whole disk, which has a density sigma into area of pi, or radius is what? 4R. So if we square it, it will become 16R square. Minus M2 is what? Sigma into pi R square. This thing I think will be difficult for you to write down the masses. What is the standard formula? Sigma is equals to mass per unit area. So mass will be sigma into area. This is the formula that I have used. Sigma is the mass density, area is the A is the area. Okay. Now solve it again. Minus is already there, sigma pi r square into 3r. And in the denominator, something is common, which is sigma into pi r square is common. What is remaining? 16 is here and 1 is here, that is 15. Sigma pi r square will be cancelled out. So it will become minus 3r by 15. That is minus ka r by 5. This means, or it means that center of mass will shift by r by 5 distance, and minus indicates that towards left. It will shift towards left. So which option is correct? R by 5 is option number D. Very good, Chichuni. This is the standard procedure. In how many type of questions it can be asked? One is center of mass that we are doing. Another is moment of inertia type of questions in which it may be asked or can be asked, very simple. Another is in electrostatics that we study in class 12. In that, I think you have studied class 12, huh? You are the pass out students. Am I right now? So you have studied that part as well. Okay, I forgot that. So you have studied that in electrostatics as well. Okay, again, there is another class 12 question. That's what I forgot. Question says, two coils 1 and 2 have mutual inductance M. Very good. And resistance R each. A current flow in coil 1 which varies with time as I is equals to Kt square. That means current is given as K into T square, where K is a constant. T is time. The total charge that flown through coil 2 between t equals to 0 to t equals to t by 2. At first, you will see that question will be something you will say that we should leave it. But actually, the question is not to be left. It's very easy question. Listen to me very carefully now. In this part, I will explain you some concept, and in this part, I will solve the question. Now, when two coils are placed nearby, what we know that phi is equals to mutual inductance times current. This is the very basic formula. You have studied that. Phi is equals to M into I, where M is the mutual inductance and I is the current in any one of the coil, which is variable actually. Now, if I want to calculate what is the change in flux, so M is a constant, so M is constant, that will be delta I. Only current is changing. So if I want to calculate change in flux, so that will be M into delta I, because only current is changing. Now again, why we are calculating delta phi? Because EMF induced in a coil from EMI chapter, I think you know that EMF induced in a coil is minus delta phi over delta T. I think this point is clear. EMF induced is what? Minus delta phi over delta T. I think there is nothing big. This is Faraday's law, second law, you can say. Now EMF is known. Now what will be the current? If I change the color of the pen, what will be the current? I is equals to E by R. Put the values. That is, I am not interested in the direction, so I am omitting the negative sign. That will be delta phi over delta T, that is E into R. This is current. The question is asking the charge, and you know that charge is equals to I times delta T. So if you place the value delta T will cancel. So Q will become delta phi over R. This is the standard relation that what is the charge flown through the coil. Q is equals to delta phi over R. R is the resistance, delta phi is the change in the coil. Now I am interested in only calculating delta phi. Let's suppose this is equation number 3. So let's start in calculating delta phi. If I say phi is equal to, according to the relation, is m into I. I is what? K into T square. From this relation, I am writing from equation 1. Phi is equals to m into I. What is the value of I given as kt square? Nothing else. I did nothing. Now, they are saying that time t equals to 0 to t by 2. That means initial is t equals to 0. So if I calculate initial flux, phi initial, that will be 0 because t is 0. And phi final will be m into k into t square. T square means t square by 4 because t is equals to t by 2 given. Final time is given as t equals to t by 2. I am squaring it t square by 4. So what is change in flux? Delta phi, if you see, it will become n k t square by 4. This is delta phi. So what will be the charge? Q is equals to delta phi by r, that is n k t square by 4 r. N k t square by 4 r. This is the concept part and this is the question part. You can see that. Moving further for the next question. This is the question of optics that we have studied. We have completed in the, I think, 1 or 2 days ago. Question says, a vessel of depth 2D. First of all, there is a vessel. There is a container, I will say. It has a depth 2D. Is half filled with a liquid of refractive index mu. It is half filled with a liquid of refractive index mu. And its upper half is filled with the liquid of refractive index 3 mu by 4. And the upper half is filled with a liquid. So this is D. This is again D. The refractive index of both the parts are, this has a refractive index mu and this has a refractive index 3 mu by 4. Question is clear. Now they are saying the apparent depth of the vessel when seen perpendicular from the above. Now if an observer is somewhere here, this is the eyes of the observer that I have drawn. So what is the depth of the container or the vessel? So what we have studied, apparent depth. Now remember this formula. In the previous class, I have not discussed this. I have discussed only one layer. Now whenever there are two layers, then actual formula will become T1 by mu1 plus T2 by mu2 plus dot dot dot. Now remember what is T1? T1 is the thickness of the medium divided by its refractive index. T2 is the thickness of the medium divided by its refractive index and so on. So according to the question, the depth is D for first medium and its refractive index is mu plus another medium also has a depth of D and refractive index of 3 mu by 4. So 4 will be something here. Clear? Now you can add them. The LCM will be 3 mu, that is 3D plus 4D, that is 7D by 3 mu, which is option number C. So what is the relation? This is the relation for which? For multiple layers. Whenever there are multiple layers, the relation that you should use is this one. This is the question I think everyone must have. So in the previous class, I have discussed this. This is based on what? Can anyone answer this question? You can solve using which theorem? Actually, you have asked this theorem in the previous class. Which theorem we should use to solve it? Be quick. Or should I solve it? Have you solved this or you need me to solve this question? Answer quickly. Using Lemmy's theorem, laws of motion. Yeah, you can solve it using laws of motion. But the actual theorem you should use, this is the same question that I have solved in the at the last of the previous class. Rotational motion class, the last topic of the rotational motion was Lemmy's theorem. You shouldn't forget that. So I am leaving it to you the same question. Only change is the mass. See, mass was different in that question, and this angle was actually 37 I have taken. Otherwise, everything is same. Nothing is different from that part. So you can solve it using Lenney's theorem. I am not going to solve it here. Moving further. There is one more question that we can take here. The question is, what has come? The question is two identical shaped bar magnets A and B are taken such that, okay, listen. There are two bar magnets A and B. The magnetic moment of A is twice of B. That means if magnetic moment of B is M, then magnetic moment of A will be 2M. Magnetic moment is denoted by M now. So is this point clear? First point is clear. Now again they are saying that time period of vibration in uniform field, there is a external uniform field when like poles are together is T1. Okay. Now they are saying that these two bar magnets are suspended in such a way that their like poles are together. Like poles are together means their north and south poles are in the same direction. Let's suppose this is north, this is south, this is north, this is south. This is bar magnet A, this is bar magnet B. And in this situation, time period is T1. Clear? Now in the second situation, they are saying when unlike poles together is T2. Now this time they have suspended it with opposite poles. This is one bar magnet, this is another bar magnet. Let's suppose this is bar magnet A, this is bar magnet B. This is north, this is south, this is north, this is south. They have changed the poles. Now this time period of revolution, time period of oscillation is T2 according to the question. Now we have to find the relation between T1 and T2. Now you can clearly see that these two bar magnets have magnetic moments 2m and m. So in the first case, the net magnetic moment m1 will be, both are in same direction. That means they will be added, that is 3m. In the second case, both are in opposite direction. So net magnetic moment will be, one is 2m, another is m. So net magnetic moment will be m. Is this thing clear to you? What is the net magnetic moment? In first case, both the magnetic moments are in same direction, so they are added. They are in opposite direction, so they are subtracted. Now, what is the formula for time period? Time period is T is equal to 2 pi under root I over MB. Now I am explaining each term. Here I is the moment of inertia, B is the magnetic field, M is the magnetic moment. Now, according to the question, bar magnets are identical. So their moment of inertia will be same. Magnetic field is given uniform, that is same. 2 pi is a constant. Clear? So T is reciprocal to root of M. So I can write T1 over T2 is equals to root of M2 over M1. Is it clear? Now, after writing this one, you can write T1 over T2 is equals to root of M2 over M1. M2 is what? M. M1 is what? 3M. You can solve it and you will get T1 is equals to T2 by root 3, which is option number C, which is option number C. So what is the formula to be remembered? This is a very important question actually. This is very important question and very famous question for NEET examination. This formula should be remembered. Time period of oscillation of a bar magnet, 2 pi I over MB. And very good question. Now I think time is up for now. Next we will discuss next chapter. Till then you can enjoy. Bye everyone. Bye Suchuni and bye everyone.